So my name's Sam Batchelet. I'm here to talk today about kind of my journeys of dealing with the new Etcd version 3 API, kind of the exploration of utilizing that with Perl. I'm going to talk about a module that I created, NetEtcd, kind of the process that I went through to do that, and kind of hit on a bunch of technology around Kubernetes, Etcd, and it's going to be, there's quite a few things going on as far as stuff I'm going to hit on. So if you have questions on this, the slides will be published, and we'll have some time at the end to kind of go over questions, but we could get easily sidetracked on some of these things for a long time. So again, my name's Sam Batchelet. I work for a web consultancy called Endpoint. They've been in business now for over 20 years. Big shout out to them for getting me here. I do appreciate it. And this is my first YAPC, so nice to be here. Just wanted to go over a few other things. The slides and everything. My nick online is HexFusion, and you can check out the slides and get on my GitHub and all that stuff for the module, etc. At hexfusion.com. All right. Just to kind of preface this a bit, how many of you guys currently use Kubernetes or are familiar with it? Okay. What about Etcd? Have you heard of Etcd or? Okay, cool. Great. So this is kind of the agenda. We're going to go through kind of the foundations of some of the communication protocols, GRPC. We're going to go through kind of a new way to allow legacy languages or legacy applications to commit to communicate with gRPC using JSON. So like a traditional REST API, which gRPC does not directly support. We're going to talk a bit about NetEtcd, which is the module that I created. We're going to touch base a little bit about Dancer, and then also kind of go over some use cases that I came up with for the module. Kind of the idea here is to kind of brainstorm and to look for opportunities where you may find Etcd could be useful in your current stack or in your applications. It's not something that's really widely used outside of Kubernetes and kind of the cloud infrastructure, but I can give some reasons as to why that might be useful. We're going to touch base a little bit on Kubernetes and also the module Net Kubernetes, just basically interacting with Kubernetes, deploying pods and services and what that all means. And then at the end, like I said, if we could just wait for any major questions to the end. If you have something small, we can certainly go over that during the talk. Can you guys hear me all right? All right, cool. Okay, so gRPC. gRPC is the predecessor of what Google had internally called Stubby. Stubby was kind of an in-house RPC, and basically it was the glue for all of Kubernetes, or again, Kubernetes, for all of their container orchestration through Borg. In 2015, Google, because of they realized that technologies and open source standards such as like HTTP2 and Speedy were coming out, that they wanted to open this up to the community and bring Stubby kind of into the next iteration, which became gRPC. So the big benefits with gRPC is that it works with a lot of different languages. So it's basically language agnostic. When I started on this kind of experiment with with STD and GRPC and this whole thing, there really wasn't, it was probably about a year and a half ago, there really wasn't a lot of Perl support that I could find. So I didn't go that route and ended up using the GRPC Gateway, which I'll get into in a little bit. But actually, you can see that GRPC is it's pluggable. So there's authentication, there's easy access to authentication layers, HTTP2 bidirectional transport, which is a real important thing when you're talking about speed on the wire. You're talking about communications with containers going across different systems. Those communications need to be fast, so GRPC facilitates that. So this is basically a basic example of a GRPC protocol file. So it's pretty basic in definition. You're not getting into a lot of typing. You're not getting into a lot of details. It's pretty straightforward. So in this case, we're dealing with, this is actually a piece of code taken from Etcd for their authentication. And it basically is just defining a user. And you can see there's the order and basic typing of bytes and such. So Protect, which is the mechanism for GRPC, which basically will compile your proto files and then put them into whatever language you're looking to accomplish. In this case, I'm going to use Go. So below the syntax there is the incantation of Protect that would produce the proto file. And we had some problems seeing this before. I don't know if we can kill the lights a little bit. The full details of this, I mean, this is Go. This is not, I don't want to spend too much time on this, but what I do want to kind of show is the details that that proto file definition create. So you can see here that there's a lot of information as far as the definition. This is a full, it'd be, you know, in Perl, this would be a full class. And it not only supports the incoming information, but also formats it for, but also you can see it formats, it does have information for JSON as well. So basically, under the hood, the details of the entire RPC call are defined in this file, which, as you can see here, they define you don't want to edit these directly. They're automated builds. So you would define the proto file and then generate the output. So yeah, it's just recently I came across this module. So this is Google Protocols Buffers Dynamic. And what this actually does is this is a plugin for Proto that gives support to Perl. I haven't played with this much, but this is very cool. What you saw at output in regards to creating a package file for Go could do the same thing in Perl. So basically it would define a full class. So I'd be interested to see what that outputs. I mean, is it moo? How are the objects defined? That type of thing. So, you know, this is definitely going to be something that I explore further. Might be something that you're interested in. All right, so so that's GRPC. Basically, I'm just laying the foundations for Etcd and the version 3 API, which is based on GRPC and Proto. So I just wanted to give a little bit of a background there. So Etcd. So Etcd, its name comes from the Etsy directory, and then the D is actually just for distributed. So Etcd, very interesting. So it's a distributed key value store. It's the kind of the foundation for data storage for Kubernetes. It's a fault-tolerant it's a fault-tolerant data store. So basically, it would be deployed in a multi-node setup, and then because of a technology called Raft, it has the ability to basically reassign leaders if one of the nodes was to go down. So if you have 5 nodes spread across maybe a data center or even just a few server racks, 2 of those go down, then you're still going to have an operational system, which is different than a traditional deployment of maybe a VM with Postgres. I mean, you could of course have a setup like this, but this comes standard, and it's part of the ecosystem. So it's really important to understand how important that is in a system like Kubernetes, who relies on this information to basically do everything, from deploy containers to understanding if the ecosystem of containers that it's supposed to be managing, if they're up, if they're down. So that data is very important. So Etcd, it's a data store, but it's not something that you want to put gigabytes of data in. It maxes out at about 8 gigabytes, and that's basically because this data needs to be replicated across the wire into all the nodes, and the more data that you have, the stability is going to go down. So small amounts of data, JSON, YAML, it's great for configs. That's why it's utilized in Kubernetes, basically just storing metadata. So the version 2 API, which is still in existence, used a traditional REST JSON API. Now, by Perl standards, by most of our standards, JSON is fast. But when you get on the wire and you have HTTP1 communications, it can get quite chatty if there's a lot of transactions going on. So what they needed to do was they wanted to move forward with bidirectional streaming, so HTTP2. Also, in the version 2 of the API, it allowed for, so it's a KeyValue store, but it allowed for you to make like directories. So basically, for example, backups. So you can see anytime you facilitate the creation of directories, you can foster poor usage. So not only were the directories and the concept of a file system abused, and that caused degradation of service when larger objects were stored in those directories, but also if you were to make a key of backups foo baz, and then put a value on baz, you just created a series of empty directories. And those directories ended up accumulating in size, and it was just wasteful. So the next incantation of the API was to flatten. They wanted to flatten the KeyValue store. That's pretty common. So the concept of directories were removed. They moved forward with RPC and HTTP2. So that was the GRPC stuff that we just talked about, and then the protobuf definition. So they're using version 2 and version 3. Most of the new stuff is now in version 3. So the goals of all this, efficiency and speed, you know, they want to be able to write a million keys. You know, they want to be able to do that in a very efficient manner across a data center. So that was kind of the target goal. So this is kind of a matrix of other key value stores that you might have heard of, mainly being Console, Etcd, as we're talking about, and Zookeeper. Zookeeper is an Apache solution. So you can see, like, from afar, most of these have similar technologies as far as they're all distributed, fault tolerance, health check, all that stuff. You know, Console is a little bit more robust in the sense that it actually has its own web UI, and it has out-of-the-box support for multi-data center, which is something the others do not. But that's kind of where the commonality comes in. Now I'm going to just kind of show how Etcd kind of on a performance level is, you know, superior to some of these technologies. So in this chart here, you can kind of see the breakdown of latency. Can anyone see that? Can you read those? Yeah, kind of. So you've got Etcd on the bottom here, and so you're talking about 3 million key reads, 256 kilobyte keys and 1 kilobyte value. So that's a tremendous amount of transfer, and the latency there is just unbelievable. So that's, you're talking about what, 8 to 9 milliseconds. So, you compare that to the other ones, you can see that there's a good amount of improvement over that. It's really, it just depends on the size. So I mean, theoretically, I mean, I guess if there was a bunch of white space, I mean, generally you're pushing JSON flat, right? So it should only matter on the actual size of the data. So I'm just going to kind of go through these quickly. One of the developers has this amazing tool, DB tester. It's really intense as far as the lengths they go through to test this stuff. And I just wanted to share some of these slides just because I thought the data was amazing. So here's CPU scaling. You can see you know, Etcd holding its own kind of in the middle of the pack there. But the one thing that's important to notice is that you don't see these huge spikes, right? It's very consistent throughout the duration of the test. Where if you saw these charts in the version 2, you would see a lot more of this type of inconsistency based on volume. Again, another slide. Just cool information. 1 million keys. That's unbelievable. All right, so here's latency. Okay, so the issues with the version 3 API was that it closed out, by using gRPC, it closed out access to a REST API. So for all of the languages with gRPC support, not a big deal. But for Perl at the time, which it's beginning to have support now, you had no way to directly communicate with the API. So, so this was a pretty big problem, and because Etcd was so widely used, there was huge pushback from the community for a solution. And what they finally came up with was a solution called the GRPC Gateway. So the gateway basically allowed the facilitation of a RESTful API from the GRPC proto definitions, and basically created a reverse proxy that took the JSON from the REST API and converted it into a gRPC call. I mean, it's like, wow, that's intense, right? So just wanted to give a shout out to Yuki. She actually came up with the idea and wrote a lot of the code on her own. The link to her GitHub is at the bottom of the slide, and it's an amazing concept. But it's still kind of scary. So you have a reverse proxy that's converting JSON into gRPC, right? I mean, it's kind of hairy. So here's kind of a definition slide of a visual of kind of how that works. You've got the proto file that we kind of talked about before, whether it's defining authentication or whatever service it may be. And then basically it splits two different definitions. The one definition is your standard gRPC service. The second is going to facilitate the reverse proxy. So at that point, you have, it's actually a really cool setup. So at that point, you have your API that can communicate directly with gRPC. So after seeing that and the lengths they went through to solve that problem, because really they were solving a legacy problem, right? So gRPC is the future of these communications. That's pretty obvious. But they still went to great lengths to facilitate this gateway, and I wanted to, at least have someone use it, right? So the experiment was NetEtcd. So what NetEtcd would do is communicate with this RESTful API and facilitate communication. So right, what could go wrong? I mean, you're taking Go, you're running it through a reverse proxy to communicating with Perl, and like what would that look like, right? Like how is that communication going to be? So this was my visual on that. Okay. So the next part of the talk, now that we kind of got the preface out of the way, sorry if that was a little bit on the DevOps or sysadmin side heavy, but figured it would help as we talk about the rest of this. So we're going to walk through kind of the key kind of features of the API, some different concepts like lease and watch, transactions, what they do and how we can use them with the module. All right, so this is a simple key value put. So in the version 2 API, there was the idea of put and get. Get is kind of replaced with the concept of range now. So this is a basic example. You can see you just got your key and value, and this is basic. This is going to return back an object which has a response from the server and also the details from the request. As far as the response objects go, they're kind of raw at this point. I'm basically giving you back quite a bit. In KeyValue, I do give some helpers, like actually KeyValue will return just that instead of dealing with the object. But in some of the other ones, I'm leaving it up to the developers to handle the response object and format that. That'll be something in the next upcoming versions that I'll change. Much like with protobufs and GRPC definitions, there's a response object defined. They outline that very well in the documentation. So I'll be moving towards confining by that. But also, if you guys pick up these slides at the bottom, are links to the modules right, directly from Latency. Okay, so Elise. So Elise is basically a time frame in seconds that is defined and attached to a keys or a series of keys. So let's say, for example, you had a key foo and you wanted it to live for 20 seconds. You would create a lease, and during that 20-second period, you have the ability to push a keep alive. So you could reset that 20 seconds and keep the lease active, or if you were to let the lease expire, the key would be deleted. So there's certain circumstances where this would be useful. Leader elections. So if you had a series of databases or whatever that are going to be distributing information, there needs to be one that is the truth, right? There needs to be one that is in charge. So setting a lease time to check in, is the leader alive? If not, okay, we need to go and find a new leader. That's an example. Aliveness testing. So, using a cron to access a route on a site to see if it's active, and then maybe have Etcd push a key that would be usable by Kubernetes or some other application to view the data. And build systems. So, think Jenkins. Every time you go through a step in a build, there needs to be a validation of it. Did this succeed? You could use a lease to define a timeout. Different steps in the build process should, send a keep alive back to the lease, and if that doesn't happen, we know something failed. I'm going to just go over this quick. I know it's a lot of stuff, but this is an example of creating a lease. So in this example, I just used math in 64 to generate the lease ID. But if you don't pass an ID, it automates it. But so it will create one for you. But for the sake of the slide, I showed how you can create that. And this goes through defining the lease and then granting it. And then once you have a lease, the time on the lease does not start until a key is attached. So if you started a 20-second lease, it's not going to expire 20 seconds later until there's actually something attached to it. So, so you can see the incantation there to add a lease to a key. And then this is an example of sending a TTL. So in this case, we're assuming, well, that the lease is still alive. If it's not, it's going to return -1. But we see this lease, it's coming down, and we want to send it back to 20 seconds. So we're going to pass TTL to it. And revoke as well. So you can remove the lease. Okay. Any questions so far? Everybody hear me? Am I rambling on too much? Quiet? Okay. More. Got it.
This slide.
Thanks. Okay. So the next one, next topic is watch. Watch is really like a cool concept. So basically you can set a watch onto a key or a range of keys, and then basically any interaction with that key will facilitate a response. So when I was building this module, one of the hard parts with that is the input and the output of a watch are streams. So when you're just using regular, I think I was using, I forget which module, but if you're just pushing JSON, that's not going to work. So I had to use any event and actually replace the transactions with any event HTML. Where that's not. It should be any event HTTP. So what that facilitated was a stream. You could inject a callback and then watch that come back as the interactions took place. So that was my first go at using any event. It was pretty interesting, especially trying to code in a non-blocking way, so that anything that you do can't block the asynchronous transaction, or it'll stop. So this is an example of a watch. It basically takes the key, and then you can see the callback sub at the end, and this is basically what's going to happen when there's an interaction with the watch. So in this case, we're just creating the watch, and then we're just going to test it, and we're going to push a key and just see what kind of reply we get. So I did a little. I hope you guys can see this. Maybe I'll full screen it. And all the code on this is you can get from the slides, but you can see this is basically the same code that we just had, and you can see the response there. So if we go back, you can see there's two results in the dumper. But if you look, there's the initial creation, but then also the push of the key, but there was no print. So that actually all took place up here. So it's kind of cool, I think. So this opens up the door. I mean, you need to be careful when you're using Watch, because you need to program and utilize this in a non-blocking way. But you have asynchronous communication with the API, which is pretty cool. All right. So transaction. This is kind of something. I mean, it was new to me. It basically is adding kind of a logic to key interactions. So basically, I thought easiest to explain it would be just with some simple Perl. I mean, the logic of this is basically, if key equals something, we're going to do a success, else we're going to do a failure. So this is kind of an example of how we would kind of come up with, we would create that. So we're going to create a put. So we're going to just create a put object. We're going to flag a hold there, which means that we're not going to actually run the transaction. We're just going to hold the object. And we're also going to do that with a range. Okay. So, and then basically we're going to define a success action, which in this case we're going to do a put. So we're going to take that put object, define it into the success. In the failure, we're going to do a request delete range. So in this case, the range is actually going to delete a key. And then we're going to put that into what's called a compare. The compare is going to take the key. The target in this case is create. There's a few different keywords that you can use there. And we're going to look for revision. So each time a key changes, the revision number changes. This is kind of a specific example where we're looking for, this is revision 1 of this key only. In that case, we get a success, and we go through the whole transaction. If there was success, the key would be created, and if there was failure, we would get the delete range. Okay, so I'm going to start kind of a little bit behind here. I'm going to start going through a few things. So a little bit quicker. Authentication issues. So because protobufs define things for GRPC, and the general way for authentication to take place is through the headers, in this case, there was kind of a separation between the ability, basically there was no authentication. And basically that was because of, I mean, it was basically in between two technologies, so it wasn't available. So after like 6 months, I just got sick of waiting on trying to fix it, and created a little script called Swag that basically the security definitions into the Swagger file. Short end of it is there's now authentication through the GRPC Gateway. So I was pretty proud of that. That's now part of Etcd. It's so recently part of Etcd, it's not yet released. So the next version that will be released will be 3.2.1. That will have the code, but I did roll up a version of it if you guys want to play with it. It's on my GitHub under Etcd. So the download there is right at the bottom of the slide. So now, you know, I went through all this building this this module and all this stuff that didn't have authentication. I thought I was going to have to bail it, but we got past that. So here's just a simple example of the authentication. It's actually a pretty cool process. So authentication will query, send the username and password to Etcd. Etcd will send back a token, and then that token can be reused for a series of time. Basically, the idea there is that you don't want to authenticate every transaction to cut down time on the wire. Okay, user roles. This is basic stuff, but I did want to go through it quickly. This just kind of goes through the Etcd does have an ACL. This goes through the process of creating a user, creating a role, attaching a key to a role, and then attaching the user to the role. So that's just basic user ACL stuff. So that's kind of the core points of the Etcd module. You know, I would be really interested in doing more work on it. I would hope that you guys would use it if you can find any uses for it outside of the norm. Definitely something, hit me up, any questions, pull requests. I'm very interested in furthering that. I'm just going to touch base real quick. Dancer, I'm assuming everyone knows what Dancer is. I did come up with just looking for use cases to utilize Etcd, came up with a plugin, Dancer plugin, Etcd. Basically, it just, at this point, it's relatively simple. It just gives you the Etcd keyword, so easy access to the module. But you know, looking for use cases and stuff, you know, Dancer would be a great tool for something to like a clone of a Jenkins or something. I mean, I ran into a situation when trying to test Etcd where I needed solid state drives, and some other stuff to facilitate that. And I mean, you know, do you really need like this giant Java framework to run a few bash scripts? You know, it's so I think that Dancer really could harness some of this stuff into a custom build tool, perhaps. All right. Again, that's kind of so. This is just basic usage. Again, it gives the keyword. This is basically just an example of what would be maybe tacking on like a keep alive type of thing as far as usage. Now this is something, this script actually basically made me declare this module experimental only, but I think it's really probably the coolest part of the module, and I'll probably break out the logic into its own module. But basically what it will do is it'll store YAML on the line level in the key value for Etcd. And it not only does that, but it maintains white space and it maintains comments. So if you're in, and basically I'm using like a Docker style naming, if you're in your app and you just would do shepherd put, it's basically going to write all your configs to Etcd as a backup. You made some changes or something's wrong and you wanted to just back that up, get it back, you just do shepherd get. You could define a version to get back, and boom, your configs are right there. It's reading its own configs out of the Dancer config as far as the plugin to communicate with Etcd, or you can pass parameters to it directly. But you know, I don't want people trying to do this in production. That would be, I've done a lot of tests on the YAML, different YAMLs, but it's kind of scary. Okay, real quick, how much time do I have? Am I pretty much done? Okay, cool. So I'm just going to spin through this just real quick. Kubernetes. A few things on the slide if you guys can take a look at. Kubernetes, you know, a lot of people think that that's a really complicated setup, and it is. But Minikube now, you can install it on your laptop and have it running in seconds. As long as there's a few basic dependencies, Docker machine, KVM. It's really cool and allows real easy interaction. Net Kubernetes, if you guys are interested in testing Perl interaction with Kubernetes, you know, there's a lot of great resources. I added some stubs for different types of YAML configs for setting up services, for deploying pods. So all that information is in the repo. So I'll just leave you guys with this. So this is kind of cool. So this is actually a website which shows a working Etcd cluster. And I'll just kind of show, I mean, I think what everyone does is like they come and just kill stuff. So you can see, so here's a 5-node cluster, and I'm basically killing off a few instances. You see that the leader election is like very fast. So you just had 2 nodes go down, and they were the leader was elected and online declaring leader status. I don't know if it was a second. So, all right. So those are kind of the details of my exploration there with NetEtcd. And any questions or criticisms? Yeah, so that was like kind of the that module that I showed the dynamic proto, the Google dynamic, and that basically is support for GRPC directly for Perl. So that's really where the communications need to take place, right? So if you want to have something that's going to interact with Etcd natively, like Kubernetes does, you'll never get the, like with authentication, just as a simple example. When I was doing testing, I ran a test where each transaction, it would pass a request for authentication. So it would ask, it would send user and password. And like after like 4 loops, Etcd just started freaking out, and it was complaining that the transactions were over 100 milliseconds. So yeah, it's not optimal. I mean, it's not something as far as, it's not perfect, but it's, it does give the ability to interact with it on a REST basis. All right, guys. Thank you.